our quiz has negative exponents and exponents of 0 and other exponent laws, not rational exponents. But what we're coming to terms with is the difference between a rational exponent, which is like a fraction in the exponent, and a negative exponent, which turns your base into a fraction. Like, right? It's enough that you can start to get these things confused and mixed up. So that's what we are working on. So this is rational exponents. Who remembers how do I express square root of 12 as a power with an exponent?
6 squared.
Is it?
Wait, no.
That would be something else. 12 to the 1/2. That's what it is. So this is like a 2 in here. When there's nothing written, it counts as a 2. So I would rewrite this as 12 to the 1/2. Exactly right. Okay. Next one. And 12 to the 1/2, I could, or like square root of 12, I could do it. It would be 3 point something, but it would be like nasty and gross. Yeah. Very nice. 27 to the 1/4. And when we start to see these different examples, we see where that fraction in the exponent is coming from. Remember, on the quiz today, no fractional exponents, so don't get that mixed up. Different from a fraction in the base. This is fractions in the exponent. What about this one?
3 to the exponent 2.
Nice. 3. So when I'm raising it to the 2, this is like what you've been doing since grade 9. That's no different than like 3 squared, except the base is different, right? But that 2 on the outside is just the same. So it's 3 to the 2, but instead it's over 5, because you're also taking the 5th root of it. It might help some people, I don't know, so just watch, I don't know if you want to write this down, to think of it like this. This is like 3 to the 1/5 all to the 2, right? If I did this part, just this part in brackets. And then how would I do this? I'd multiply the exponents, and a 5th times 2, multiplying fractions, you just multiply tops, multiply the bottom, so it's 2/5, right? So it's the same thing. Okay, next one. You can try this one if you like. The instructions for this just say to express as a power. So I want to take the 19. And what do I do with the -3? And what do I do with the 7? Well, the 7 is the root, so it goes on the bottom. And the -3 goes on top. And I can leave it as a -3. We know what a negative would do. Nice little review. It could, if you had to. In this case, our instructions don't tell us to get rid of negative exponents, so we're done. Right? If this was a quiz question or whatever. But you could also go 1 over 19 to the +3 over 7 is what the negative would do, but in this case you don't have to. Same thing for E. How would I just rewrite the powers? I'm going to do 1 over 11. And who can tell me what my exponent would be? Eunice, what do you think? Very nice. 13 goes on top, and the 6 is the root, goes on the bottom. And if I wanted to, for whatever reason, flip that to the top, I could write it as 11 to the -13 over 6. Any questions about any of that? So that was just rewriting as a, yep. No, that never changes the base. Flipping things around is a property of the exponents. The base doesn't change. So 11 is the base. It stays the same. Good question. Okay, now this is going the opposite direction. So express each of the following as a radical. Put it in radical form. The other form, basically. A lot of people probably aren't used to that word radical yet, but it's like the other one. If you're giving it like this, you're writing it the other way. So I always use that symbol. The base is the 6. It goes inside that symbol. I wrote this one really big for some reason. And then the 9, which is in the denominator of the exponent, the fraction in the exponent, goes there. And you could think about all of this to the 1 because of the 1 on top, but raising something to 1 doesn't change anything, right? That doesn't actually do anything, so that's why we don't bother writing it. Compared to the next one,
cube root 71 squared.
Yeah, so cube root or third root, both are really good. And then I can put this in brackets and I can do squared, or I could do cube root of 71. As long as you write it clearly, I can just put the 2 on the radical sign like that. Or you might have seen this in the practice. If you completed all the practice yesterday, I could put the 2 inside just on the 71 as well. It will not make a difference in your final answer. Okay? So you could write it that way as well. Sometimes it gets written that way. I don't want that to confuse you, so it's important to see that as well. Okay, we're going to move on. We're just doing a bunch, like a handful more examples, and then take up the learning goal and start the quiz. So we got lots of time for the quiz. What about this one? So you could start with, if you're not sure where to start, you could start with taking the 710, which is the base, and putting it inside there. And then you have to think, what do I do with the 7 and the 11? So the 11 is in the bottom, so it goes here. And whether you use brackets or not, however you decide to write it, the 7, and I got to include that negative, so I'm going to put the negative on the 7. You would not put the negative on the 11 in there, ever. Everybody good with that? Writing as a radical. Okay, awesome. Now this one says evaluate and leave answers as fractions where possible, which is every question, it turns out. You may or may not rewrite this one. It is important that you learn how to do these, evaluate these on your calculator, whether you use the button that looks like this. It might look like this, y root x, or 3 root x, or just root x if you're taking the square root. Or like I said, mine just has boxes, so mine looks like this. Or you could use the exponent button if you have fractions, and you could do 125 to the exponent, 1 divided by 3. But somehow you have to be able to do it. If I was doing this as a radical, I would do cube root of 125. You don't have to show that step. But you probably want to get your calculator out right now, and ideally not your phone, because you can't use that on a quiz or a test. But if you don't have that handy, that's fine. If you need to, there's calculators up here somewhere right here that you could borrow, but all the ones in here aren't great, so if we need good ones, I'm going to have to go get them for this stuff. But you got to learn. So like now's the time to learn. When the test comes and you say, okay, now can you teach me how to use my calculator? No, like we were supposed to do that before, right? So make sure you figure it out and practice a little bit. Who's got this answer? 5. And why? Because 5 cubed is 125. So we're doing the opposite of that, right? What about this one? There was one like this in the practice yesterday, 1 or 2. We didn't really do one like that, so I was hoping you'd think about it. How would I do this one? Yeah. It does. 0.25 is a quarter, like 25 cents. So this is the same as 16 to the 1/4. which is the 4th root of 16. Who's got that one? But again, on your calculator, you could put 16 to the 0.25. But if it said rewrite as a radical, you'd have to be able to convert it. So you can't just rely on your calculator. You got to know how to apply the rules, but you also need to know how to evaluate. 2, very good. 2 to the 4 is 16, so the 4th root of 16 is 2. This is one, again, where it can be very helpful to be able to rewrite it. Give it a try.
Square root 25 cubed.
Square root of 25 cubed. Nice. Square root of 25 is 5. 5 cubed is 125. What if I had done it this way? Square root of 25 cubed. So 25 to the 3, 25 to the 3 is going to give me a really big number. And if it was to the 4 or to the 5, it's going to go off the calculator pretty fast because exponents get big really fast. And even 15,625, I don't really want to have to write that if I don't have to. But you only have to do this in one step. If I take the square root, I get the same answer. So that did equal the square root of 15,625, which still gives me 125. You can decide which order you like to do it. Sometimes it might be a little bit simpler to do it one way. Sometimes it might be better to do it the other way. I don't know. Just depends on the question. Both work, but sometimes it's nice to avoid big numbers. And sometimes, like I said, the numbers get so big, your calculator can't even handle them. So you wouldn't know what to write down. 36 to the negative 1/2. So we have to evaluate this as a fraction. What does the negative do? Review for our quiz. Yes, Nanette. Flips the 36, right? So this is like 1 over 36 to the 1/2, which is 1 over the square root of 36. And what's the square root of 36? Tanner, do you know what it is? So we're going to write 1 over 6. Sometimes people go from 1 over 36 to just equals 6. They forget the 1 over in their last line, but you need that. On my calculator, I would type in, if I had to, if I didn't just know it, square root 36 equals, and then write 1 over 6. Stop me if there's questions. We'll keep trucking. Try this one. At least try the first step. If you think you can do more than one thing in the first step, go for it. But if you make mistakes doing too many things in a step, then break it up into multiple steps.
You would do this button right here. See the little X with the square root, and that'll do any square root. So you go 3, second function, hit that button. So it's going to take the third root.
How would I use my calculator to figure it out?
Yeah, so let's say you were doing the 4th root of 16, like that one question. 4, second function, this button, see the little X with the square root, and then type in 16.
Oh, okay.
So what I'm going to do to begin this question is I'm just going to handle the negative. But some people might think like, oh my gosh, that's too many steps to write out. And as long as you know what you're doing and you're getting the right answer, it's fine. So I'm going to just handle the negative. So I end up with 25 over 4 all to the positive 1/2. And what do I do when I have an exponent for a fraction?
You divide it, so we square root of 25.
Yeah, the exponent applies to both parts of the fraction because it's in brackets. And so you could like again go 25 to the 1/2 over 4 to the 1/2, but probably at this point you're just going to go, so 1/2 is just the square root of 25 over the square root of 4. And that is?
5/2.
Nice, 5/2. Try the next one if you like. It's the same idea. Sorry, not quite the same, but similar. Pearson, what'd you do there as a first step? Flipped it. And what'd you get when you flipped it? 1/32. How many people did that? Just took care of the negative in their first step. Nice. So 1/32 all to the positive 2/5. And then I can handle the 2/5. So the 1 doesn't matter because raising it to any exponents won't change it. So this ends up being the 5th root of 32 squared. This would be a really good example of like, what is 32 squared? Oh, square root. What happened there? I hit the wrong thing. Clear. 32 squared. Oh, no, that is squared. It's not as big as I thought it might be. If it was to the 3 or to the 4, it would get really big.
So, wait. We're going to 32.
So the 5th root, no, I'm going to do the 5th root first. Which is?
Oh, 2.
2. The 5th root of 32 is 2. So this is like, you wouldn't have to show this, but 1/2 squared, which is 1/4. Because I did 32 squared first. Remember how I said you could put the 2 inside? And it wasn't as big as I thought. I thought it would be kind of big, but. Okay, same thing. So I took care of the negative first, then take care of the exponent by rewriting it in radical form so I can see that it's the 3rd root of 125. And that's going to give me 5, so it's going to be 5 squared. 3rd root of 8 is 2, so it's going to be over 2 squared. And if you want to do that as a separate step, you can. I'm kind of doing it off to the side just to remind us that there's sort of those 2 steps. And then this gives me 25/4. We good? Okay, a couple more. Again, these are just different kinds of questions. What would we do when we had a decimal? It totally depends on the situation. In some cases, you might leave it as a decimal. What if I wanted to convert this to a fraction? What is 0.04 as a fraction? Kind of. I multiply it by 100 in this case, but then, it would be 4, but I have to make it over 100, the thing that I multiplied it by. So good. So this 0.04 would be 4/100. Why did we choose 100? Because there were 2 decimal places. So I chose a 1 with 2 zeros. That clears the decimal. But then I have to put it over 100. Try 4 divided by 100 on your calculator. You get 0.04. You can always check. And what is 0.5 as an exponent? Or like, if I want to rewrite it so I understand it better. A half. So this ends up being the square root of 4 over the square root of 100. Square root of 4 is 2. Square root of 100? Shout it out. Who knows that? 10. And this can be reduced. If you can reduce it, you should. That's something you should try to get used to. Divide the top and bottom by 2. Especially if you're doing if you're practicing, the answers will be reduced. So if yours doesn't match, that might be why. Stop me if there's a question. We got 2 more here to do that are similar. So I'm going to do this one the same way. There's 2 decimals. Yes, there's a number before the decimal place, but I don't care about that. So this works out to 144 over 100. And again, 0.5, so all to the 1/2. What's the square root of 144? 12. We already did the square root of 100. It's 10. And I can reduce this. Does anybody know what 12 over 10 is when you reduce it? Sarah? Nice. Okay, try J. Careful. You got to count the decimals. It's a bit different. See if you can figure it out. It's the last example. So some people were doing different things that I saw, but you might be like, okay, so the number on top is going to be 49. Like if you're good at kind of spotting that stuff, you know that part. How do you figure out what goes on the bottom? Just count the decimal places. So 1, 2, 3, 4. And it's going to be a 1, 1, 2, 3, 4. So in this case, that's 10,000. To the 1/2, which is the square root of 49 over the square root of 10,000. You can do that on your calculator. Square root of 49? 7. Square root of 10,000? 100. Be careful. I would double check on your calculator because it's going to be one of those things. Is it 100? Is it 1,000? Is it 10,000? That kind of thing. And that's not reducible, so we're done. Any questions? The handout is, again, going to be posted on the classroom. It will be available at the end of the quiz. And those are the questions that I want you to do. I'll leave that up for now. We're going to take up the learning goal and start the quiz.